You are in a spaceship. The fastest spaceship ever built. Engines roaring, pushing harder, faster, closer to light speed. 99% the speed of light. Your engines are at maximum. You pour in more power, more energy. You want to break through. You want to go faster than light. What happens? Nothing. You don't speed up. You just get heavier weight. What? You get heavier. Your mass increases. The ship becomes harder to push. You add more power, more fuel, more thrust. The ship gains mass even faster. It fights you, resists. Like pushing through molasses that gets thicker the harder you push. This isn't science fiction. This is reality. This is what actually happens. The speed of light isn't like a wall you can break through with enough force. It is not like the sound barrier. It is not an engineering problem. It is deeper than that. Much deeper. Let me show you what I mean. Richard Feynman understood something most people miss. The speed of light limit isn't about light. It is about time itself. It is about what time actually is. And once you see it, once you really understand it, you can't unsee it. But we need to start somewhere simpler, somewhere everyone can grab onto. Let's talk about rotation. You've got a wheel, a simple wheel. You spin it. The center barely moves. But the edge is flying. The farther from the center, the faster the edge moves. Now make the wheel bigger, much bigger, a mile wide. Spin it at the same rate, 1 rotation per second. The edge is now moving over 3 miles per second. Fast, make it bigger, 1,000 miles wide. Still 1 rotation per second. The edge is moving thousands of miles per second. Keep going. Make it light years across. Spin it once per second. The edge would have to move faster than light to complete 1 rotation. But it can't. The universe won't allow it. What happens? Does the wheel break? Does it stop spinning? Number something stranger. Much stranger. The wheel can't stay rigid. This is the first hint. There is no such thing as a perfectly rigid object. Nothing can be perfectly solid, because if it were, you could push one end and the other end would move instantly. Information would travel faster than light, and that is impossible. When you push something, when you actually push it, what happens? The atoms at the point of contact compress. They push on their neighbors. Those push on their neighbors, a wave of compression travels through the material. That wave is the speed of sound in that material, and the speed of sound is always, always less than the speed of light. Push a rod, a long rod, a light, year-long push one end. The other end doesn't move right away. It takes time. Over a year, the push propagates at the speed of sound through the material. Nothing is rigid, everything flexes, everything is give, because rigidity would require instant communication, and instant is faster than light. Now here is where it gets interesting. Where Feynman saw something others missed. Imagine you are on that giant wheel. Standing at the edge, the wheel is trying to spin faster. You are being pulled toward the center by the structure of the wheel. But you are also trying to fly off from centrifugal force. As the wheel spins faster, as you approach light speed, something has to give. And what gives is time. Your clock slows down. Literally, physically, actually slows down. This isn't an illusion. This isn't about what you see. This is about what is time dilation. The closer you get to light speed, the slower your time passes relative to someone at the center. At exactly light speed, your time would stop. Completely, no time would pass for you at all. But you can't reach that. You can't get there, because to get there would require infinite energy. And infinite doesn't exist in our universe. Let me be clear about what this means. When we say your clock slows down, we don't mean the clock is broken. We mean time itself is passing more slowly for you. Your heartbeat slows down, your thoughts slow down. The decay of atoms slows down. Everything slows down. Not because something is wrong with you, but because time itself is moving at a different rate. And here is the thing that breaks most people's brains. It is not that you notice time slowing down. From your perspective, everything feels normal. Your watch ticks at the same rate it always did. 1 second per second. But when you compare your watch to someone who wasn't moving, you find that less time has passed for you. Much less time. This is real. This happens. We've measured it. Atomic clocks on airplanes. atomic clocks on satellites. They run at different rates depending on their speed and their altitude. Not by much, nanoseconds, but measurably, predictably, exactly as Einstein predicted. Now, Feynman asked a different question, a deeper question. He asked, what is time? Most people think time is something that flows, like a river always moving at the same rate. 1 second per s-second, forever, everywhere. But that is not what time is. Time is change. Time is what we measure when things happen, when particles move, when clocks tick, when hearts beat. And here's the key insight. The rate of change has a limit, a maximum. That maximum is the speed of light. Not because light is special, but because the universe itself has a maximum rate at which cause can lead to effect. Think about what causes means. You push something, it moves. That is cause and effect. But the push has to propagate. It can't happen instantly. The information that you pushed has to travel from your hand to the object. That information travels as a wave through the electromagnetic field, and that wave travels at the speed of light every interaction. Every force, every cause, and every effect. All of it propagates at the speed of light. Not faster, ever. Gravity, speed of light. If the sun disappeared right now, we wouldn't feel it for 8 minutes. The Earth would keep orbiting where the sun was for 8 minutes. Then the gravitational field would update, and we'd fly off in a straight line. Electromagnetic forces, speed of light. Push an electron, it doesn't push the electrons next to it instantly. The electromagnetic field updates. The change propagates outward at light speed, strong nuclear force. Weak nuclear force, all of them, light speed. That is the maximum rate of interaction. Now here is where Feynman's insight becomes crystal clear. Mass, what is mass? Mass is resistance to acceleration. Push something massive. It accelerates slowly. Push something with less mass. It accelerates faster. Same force, different acceleration. But why does mass resist acceleration? What is it about mass that makes it hard to push? Feynman realized mass is stored energy. EFAM, CFA. Everyone knows that equation. Most people don't understand what it means. It means mass and energy are the same thing. Different forms of the same thing. Mass is just energy that is not moving. Energy that is bound up in the structure of particles. And when you try to accelerate something, you are not just moving it. You are increasing its energy. You are adding to its mass. The faster something moves, the more energy it has, the more energy it has, the more energy it has, the more mass it has. The more mass it has, the harder it is to accelerate. It is a feedback loop, a vicious cycle. At low speeds, this effect is tiny, negligible. You don't notice it, but as you approach light speed, it becomes dominant. It becomes everything. At 90% light speed, your mass has more than doubled. You need twice as much force to accelerate at the same rate. At 99% light speed, your mass is 7 times higher. At 99.9%, it is over 20 times higher. At 99.99%, over 70 times. The closer you get to light speed, the more your mass approaches infinity. And to reach light speed would require infinite energy to push infinite mass, which is impossible. This is why nothing with mass can reach light speed. Not because of some arbitrary rule, not because we haven't built a strong enough engine, because the universe itself, the structure of space-time itself, prevents it. Light can travel at light speed because photons have no mass. Zero mass. They're pure energy, no rest mass at all. So they move at the maximum rate. The speed of causation, the speed of change. Everything else, everything with mass, can only approach that limit. Never reach it, never exceed it. But here is the question that haunted Feynman. The question that should haunt you too. Why is space-time structured this way? Why is there a limit at all? Why does the universe have this maximum rate of change? And the answer is so strange, so fundamentally weird, that even physicists who work with it every day struggle to wrap their heads around it. The answer is, space-time is not what you think it is. You think space is space and time is time. Separate things. You move through space. Time passes. Independent. Wrong. Completely wrong. Space and time are not separate. They're woven together, mixed, combined into a single thing. Space-time, 4 dimensions, 3 of space, 1 of time. But they're not just sitting next to each other. They're fundamentally connected. And here's the thing that makes it work. Here's the thing that makes it consistent. Space and time have opposite signs in the equations. When you move through space, you move less through time. When you move through time, you move less through space. It is like you have a fixed budget, a fixed amount of motion through space-time. If you spend it all on spatial motion, you have none left for temporal motion. If you spend it all on temporal motion, you have none left for spatial motion. Sitting still, you are moving through time at maximum speed. 1 second per s-econd. Moving through space fast, you are moving through time slower, less than 1 second per s-econd. Moving at light speed, you are not moving through time at all. 0 seconds per s-econd, frozen. This is why light doesn't experience time. From a photon's perspective, it is created and destroyed in the same instant. It travels across the universe, billions of light years, but from its perspective, no time passes, none. And you can't go faster than light because you can't have negative time. You can't move backwards through time by moving forwards through space. That would break causality. That would allow effects to happen before causes. That would unravel the entire structure of reality. The speed of light is the speed at which you stop moving through time. That is the limit. That is the wall. You can't go further because there is nowhere further to go. Now, Feynman didn't just understand this mathematically. He understood it physically. He understood what it meant for how the world actually works. Let me give you an example. One of Feynman's favorites. You are shining a flashlight. Light comes out. Photons stream away at light speed. Fine. Now you start running forward while shining the flashlight. How fast is the light moving now? Common sense says light speed plus your speed. Just like if you throw a ball while running, the ball goes faster. But that is wrong. The light still moves at light speed, exactly light speed, not a bit faster. How is that possible? You are moving. The light is coming from you. How can it not be going faster? Here is what is actually happening. When you start moving, your time slows down. Not much. At running speed, it is imperceptible, but it slows, and distances in front of you contract. The space itself compresses. These two effects, time dilation and length contraction, combine in exactly the right way so that when you measure the speed of light, you get the same answer as when you were standing still. The light is covering less distance because the distance is contracted in less time, because your time is dilated, and the ratio comes out the same. Always the same. Light speed. The universe adjusts space and time to keep light speed constant. Not because light is special, but because space-time has this built. In structure, this built. In geometry. Feynman called this the principle of least action. The universe always takes the path that minimizes a certain quantity called action. And when you work out what that means, when you calculate what path minimizes action, you get special relativity. You get time dilation, you get length contraction, you get the speed of light as a limit. All of it falls out from this one principle. The universe is lazy. It takes the easiest path, and the easiest path is the one that keeps cause and effect working, the one that keeps the speed of light constant. Now here is where it gets really beautiful, really elegant. Feynman found a way to think about all of this using what he called path integrals. Imagine a particle going from point A to point B in classical physics. It takes one path, a straight line if nothing's in the way, a curved path if there is a force acting on it. One path, the path but Feynman said, number the particle doesn't take one path. It takes every path simultaneously. Every possible path from A to B, straight lines, wiggly lines, loops, everything, all at once. Each path has a probability, and you add up all the probabilities to get the final answer. Where the particle ends up, how likely it is to be there. And here is the thing. When you do this calculation, when you add up all the paths, most of them cancel out. They interfere destructively. The crazy wiggly paths cancel with other crazy wiggly paths. What is left? The classical path, the straight line, or the curve if there is a force. But not exactly. There is a little bit of fuzz, a little bit of uncertainty. That is quantum mechanics. That is where the weirdness comes from. The particle actually does explore all those paths. We just see the average, the most probable result. And the speed of light? It appears in the path integral. It is built into the structure. It is the maximum rate at which these paths can propagate. The maximum speed of causation. Feynman showed that you can derive all of special relativity, all of quantum mechanics, all of it from this one idea. Particles take all paths, add them up. See what you get. It is beautiful, elegant, simple in concept, incredibly difficult in practice, but it works. It predicts everything we've ever measured about the behavior of particles, everything, and at the heart of it, at the core of the whole thing, is the speed of light, the maximum rate of change, the structure of space-time itself. This is what Feynman uncovered. Not just that light speed is a limit, but why it is a limit, what it means for it to be a limit, how the whole universe is constructed around this one fundamental constant. It is not a speed limit like a speed limit on a highway. It is a structural limit, a limit on how fast information can move, how fast cause can lead to effect, how fast change can propagate. And once you see it, once you really understand it, you can't look at the universe the same way ever again. Let's do an experiment, a thought experiment. One that will show you exactly why faster than light travel isn't just hard, it is impossible. Logically impossible. You've built a spaceship somehow, doesn't matter how. You've violated all the physics we just talked about. You are going faster than light, congratulations. You leave Earth heading toward a star for light, years away. You are going twice the speed of light. From Earth's perspective, it takes you 2 years to get there. Now here's the problem. Your friend on Earth watches you leave. They see you accelerate. They see you disappear into the distance. 2 years pass. They receive a signal from you saying you arrived. Fine, no problem yet. But now let's look at it from the perspective of someone moving. Someone in a spaceship, passing Earth at high speed. Let's say 80% the speed of light, from their perspective. Because of time dilation and length contraction, the order of events is different. The geometry of spacetime is different. What is simultaneous for them isn't simultaneous for the person on Earth. And here is the thing. If you are going faster than light, there exists a reference frame, a perfectly valid reference frame, where you arrive before you leave. Read that again. You arrive at the destination before you leave Earth. Effect before cause. The signal that you arrived gets sent before you departed. That is not just weird, that is impossible. That breaks causality. That breaks the fundamental structure of cause and effect. And you could use this to send information backwards. In time, you could create a paradox. You could receive a message telling you not to leave before you decide to leave. The universe doesn't allow this. Not because it is checking every event, not because there is some cosmic referee, because the structure of space-time itself makes it impossible. Faster than light equals backwards in time always. In some reference frame, it is built into the geometry. And backwards in time breaks everything. Everything, the entire logical structure of reality collapses. So the universe has a choice. Either allow faster than light travel and accept that cause and effect are meaningless, or enforce light speed as a limit. It chose the second option. Light speed is the limit, period. No exceptions. Now, people try to get around this. They propose wormholes, warp drives, exotic solutions to Einstein's equations. Let's talk about those. Wormholes, the idea is simple. Space-time is curved. What if you curve it so much that you create a shortcut, a tunnel through space-time connecting two distant points? You travel through the tunnel. You get there faster than light could get there going the long way around. Sounds good, except for one thing. Every solution we've found that creates a wormhole requires negative energy, negative mass, something that pushes instead of pulls. Does negative energy exist? Maybe. Quantum mechanics suggests it might. The Casimir effect shows something like it. Two metal plates in a vacuum pushed together by what looks like negative energy in the space between them. But that is a tiny effect, tiny. We're talking about forces measured in micronewtons. To create a wormhole big enough to travel through, you'd need negative energy equivalent to the mass of a star. Maybe more. We have no idea how to create that. No idea if it is even possible. And even if you could, the wormhole would be unstable. It would collapse. You'd need to hold it open with more negative energy constantly forever. And here is the real problem. Even if you could do all that, even if you could create a stable wormhole, it still doesn't let you travel backwards in time. You can only go backwards to when the wormhole was created, not before. So you can't use it to create paradoxes. You can't break causality. The universe finds a way to protect itself. Warp drives. Same story, the Alcubierre drive. The idea is you don't move through space. You move space itself. You compress space in front of you, expand space behind you. You surf the wave, space is moving, not you, so you don't hit the light speed limit. Clever, except, again, negative energy, lots of it. And the math shows something else, something worse. As you travel in the warp bubble, you can't control it from inside. You can't steer. You can't stop. You have to set up the bubble from outside before you get in. And when you arrive, when the bubble collapses, all the energy you accumulated on the way, all the particles you swept up, they get released in a burst, a deadly burst. Like a gamma ray explosion, enough to sterilize the planet you are trying to reach. Not exactly practical plus. The same causality problem. If you could use it to go faster than light, you could use it to create time paradoxes. The universe doesn't allow it. Every loophole we find, every clever trick, it either requires impossible materials, or creates instabilities, or breaks causality. Every single one. The universe is very, very good at protecting the speed of light limit. Now, let's talk about what this means. Really means for us, for the future. For our place in the universe, the nearest star is 4 light years away. That means even traveling at light speed, it takes 4 years to get there. We can't travel at light speed. We can get close. Maybe 90%, maybe 99% if we're really ambitious, but never quite there. 90% light speed. It takes about 4.5 years to reach the nearest star. From Earth's perspective, from the perspective of the travelers, less time passes. Maybe 2 years. Time dilation helps. But still, years. The nearest interesting star system, 10 light years, 20 light years. The galaxy is 100,000 light years across. The universe is billions of light. Years in extent, we're trapped. Not by technology, not by lack of imagination, by the structure of space-time itself. We can explore our local neighborhood. Maybe, if we solve the engineering challenges, propulsion, life support, radiation shielding, but the galaxy, the universe, forget it. Unless we change what we are. Unless we become something that doesn't mind waiting centuries, millennia, unless we send machines, AI, something that doesn't care about time, or unless we find a way to make wormholes work, which might be impossible, probably is impossible. This is the reality. The speed of light isn't just a limit on how fast we can go. It is a limit on how far we can reach, how much of the universe we can ever touch. And it is lonely. It is isolating, because it means every civilization in the universe is in the same boat, trapped in their local bubble, unable to reach out, unable to connect. If there are aliens out there, and statistically there probably are, we'll never meet them. They're too far away. Even if they're trying to reach us, even if they're sending signals, the signals take years to arrive. Decades, centuries. By the time we hear them, they might be gone, dead, extinct. We're shouting into the void. And even if someone shouts back, we won't hear them for longer than human civilizations have existed. This is what the speed of light means. This is the cage we live in. But here is the thing. Feynman understood something that most people miss. Something important. Something hopeful. In a way, the speed of light limit isn't a punishment. It is not the universe being cruel. It is a consequence of the universe being consistent, logical, structured. If the speed of light weren't a limit, if causality could be violated, the universe wouldn't make sense. Cause and effect would be meaningless. Logic would break down. Nothing would be predictable. Nothing would be understandable. The speed of light limit is the price we pay for living in a universe that can be understood. A universe with laws. A universe where experiments give consistent results. A universe where knowledge is possible, and that is a trade worth making. Feynman spent his life exploring those laws, finding patterns, making predictions, testing them, and he found something beautiful. The universe is comprehensible. Difficult. Yes, strange, absolutely, but comprehensible. We can understand why light speed is the limit. We can derive it from first principles. We can test it. We can use it to make predictions about things we've never seen, and those predictions turn out to be right. That is power. That is knowledge. That is what science gives us. Not unlimited travel, not magic, not wishes granted, but understanding, deep, real understanding of how things actually work. And once you have that understanding, once you really see how the pieces fit together, it is more satisfying than any fantasy, because it is real. The speed of light is the limit, because space-time is structured, because cause and effect have to propagate, because information has a maximum transmission speed, because time and space are not separate, but woven together. Every test we've done confirms this. Every experiment, every measurement, GPS satellites, particle accelerators, cosmic rays, astronomical observations, all of it fits. All of it makes sense. We're not guessing. We're not making it up. We're reading the universe, listening to what it tells us, and it is telling us something profound. The universe has rules, deep rules, and the speed of light is one of them. Maybe the deepest one. And here is the final thing. The thing Feynman really wanted people to understand. The thing he spent his whole career trying to communicate. Physics isn't about memorizing facts. It is not about equations. It is about understanding. Really understanding. Getting it in your gut. Feeling why things have to be the way they are. Why does light speed have to be the limit? Not because Einstein said so, not because experiments showed it, but because the alternative doesn't make sense. Because a universe without that limit would be chaos, would be incomprehensible. Once you see that, once you really get it, you don't need to memorize it. You know it, it is obvious, it is necessary, it couldn't be any other way. That is what Feynman meant by understanding. That is what he was after. Not just knowing the answer, but knowing why the answer has to be that answer. And the speed of light, it has to be the limit. The universe wouldn't work otherwise. Couldn't work otherwise. Space and time would come apart. Cause and effect would break. Logic would fail. Reality would collapse. The speed of light holds it all together. It is the glue, the structure, the skeleton of space-time. And we figured that out. We humans, with our limited brains and our short lifespans and our tiny perspective. We figured it out. We looked at the universe and we understood something fundamental about it. That is incredible. That is beautiful. That is worth celebrating. We're trapped in our light speed bubble. We can't escape. We can't reach the stars. Not really, not the distant ones. But we can understand why. We can see the structure. We can grasp the pattern. We can know the truth. And that is its own kind of freedom. The freedom of knowledge. The freedom of understanding. Feynman lived in that freedom. He reveled in it. He spent his life exploring it. And he tried to show others how to find it too. Not everyone gets it. Not everyone wants to. It is hard. It takes work. It takes thinking. Real thinking, deep thinking, but for those who do get it, for those who put in the effort, who really try to understand, there is a reward, a profound reward. You see the universe as it is, not as you wish it were, not as stories tell you it should be, but as it actually is. Strange, beautiful, consistent, logical, structured, and limited, definitely limited, by the speed of light, by the structure of space-time, by the laws of physics. But those limits aren't walls. They're not barriers. They're features. They're what make the universe comprehensible. Without limits, there is chaos. With limits, there is structure. There is pattern. There is understanding. The speed of light is the ultimate limit, the hardest limit, the most fundamental limit, and that is what makes it beautiful. Not because it lets us do what we want, but because it shows us what the universe is, really is, at the deepest level, and that knowledge, that understanding, that is what Feynman uncovered. That is what he tried to share. The speed of light isn't just the limit. It is the key to understanding space, time, causality, reality itself. And now you have it. Now you know. Not just that light speed is the limit, but why. What it means, why it has to be that way. The universe showed us its deepest secret, and we understood. We really understood. That is the power of physics. That is the beauty of science. That is what Feynman gave us. Not comfort. Not ease, not unlimited possibility, but truth, deep, real, unshakable truth. The speed of light is the limit, and that is exactly how it should be.